So we're going to cover a little bit of, Todd, is there anything you want to say?
No, that's good. You're doing great. Keep on going, man. Don't let me slow you down.
All right, so we're tag teaming, obviously, as you've probably been able to tell, that there's two of us up here. One that looks like this, and another one that looks normal. So we're gonna. I think they know that. So we're going to talk about the infrastructure to get started with. How many of you, just so that we know, how many of you have implemented NSX in your environment in production as of now? Show of hands, please. Ah, good. That's more than half. Outstanding. How many of you have just seen it in lab and just work with it in lab? Okay. All right, very good. So a little less than half. That's good. So most of you have seen it. How many of you don't know how to spell it? Okay, there's a couple of you. That's good. That's good. We'll give you the N and the S and see if you can figure it out. NSX. I shouldn't say this out loud, but I'm going to. Last year, we were walking around, and one of the ladies that gives directions on us said, "Everybody's asking me about this NSX. This NSX, what is it?" I said, "No sex." She said, "NSX does not stand for anything. NSX is NSX." Right, and it's not an acronym. So we're going to look at the infrastructure and how the communication takes place a little bit, and then we're going to look at the NSX Central CLI that just got introduced to us a couple of months ago, 6 months or so, in version 6.2, where we can do some centralized troubleshooting, and then we're going to look at the tables, and we're going to demystify those tables. The three tables that get set up that you're familiar with in the controllers that are set up for the VTEP table to identify the different hosts, the MAC table to identify which host a VM lives on, and an ARP table so we can get rid of some of the ARP broadcasts that are necessary. So that we're going to look at those, how they're built, and all that good stuff. And then we're going to talk about a feature that was introduced in 6.3 called CDO, or Controller Disconnect Mode. And we're going to take you through that as a fabulous feature that prevents some disconnects that could take place. And so that's what we're going to do. Does that sound like something you were planning on? I got at least one nod. That's good. And I don't think he fell asleep when he, hopefully. One guy in back said he doesn't want his snoring to interrupt the presentation. So hopefully we won't get any snoring going on. Infrastructure communication takes place. This little picture that describes the management plane, control plane, and data plane. I'm sure you've probably all heard of those three planes, right? Our communication for our VMs is taking place here down at the bottom. Right down at the bottom, we've got our hosts. You probably can see the picture of the hosts sitting there. They got the arrow pointing to them if you can't figure it out without. And above those hosts, we've got VXLAN and distributed routing and distributed firewall and the switch security module that are all VIBs that are installed on that host. Where'd they come from? Well, those things came from the NSX Manager, right? They were installed when you went through your host prep to get that done. Now, if we move up, I'm going to come back to that purple in a little while. I'm going to go up to blue for a minute. There's two things listed in the blue. Okay? The two things that are listed in the blue are the controller cluster. You probably recognize it because there's a certain number of controllers that go in a controller cluster. What's the magic number? 3. You guys are great, right? Every single controller cluster has 3 nodes in it, except the ones that all those people that have their hands up that work in a lab. You know, sometimes you might just put 1. You'd never put 2. That would be wrong. Okay? If you create 4, what's going to happen? They're going to argue. They would just, you know, they'd fight. It's as if you go, no, actually, the 4th one won't join the cluster. The 4th one you build, it doesn't join the cluster. So the magic number, 3, of course. There's another device sitting in that control plane. That other device is the virtual machine that is used for the distributed logical router for dynamic protocols, right? And most of you know of it already, or many of you probably know of it. If I'm going to use OSPF or BGP, I got to have a single contact point, because where does a distributed router live? On the host, everywhere. I like that. Everywhere. I like it. I like it a lot. Everywhere. The distributed logical router exists on every single host, right? And so if I had to have every single host communicating with an upstream router to get dynamic routing protocol information, that's a mess. So we got one. And then how does he present his information to the hosts? He gets updated from all of the upstream routers. He gets that information, and then how does he get it there? Well, I'll touch on it now. I'll mention it again, but see NetCPA right there? That is the communication channel between the controllers and the hosts. And so when the distributed logical router control virtual machine, go ahead, say that 3 times fast. The DLR control VM communicates through the controllers to the host with the updates of the routing table. Okay, so that's all taking place with NetCPA. I'll go up for a second to management, and probably I should have started there because that's where it all starts after all. We have 3 items listed in that light green box. One item is the NSX Manager. The NSX Manager does not exist by himself out there, right? He needs to be associated with what? vCenter. Okay? Now, most of us, I don't know about everybody in the room, most of us as instructors, we're teaching NSX. We're teaching NSX by connecting to vCenter and using the NSX connection to do all of our configuration. Perfect, right? That's the way it should be. But a lot of people like to use different cloud management protocols or cloud management programs. And as long as it's REST API, we can manage that NSX Manager directly from any cloud management application that we got. Okay? And then that stuff gets pushed. Okay? The NSX Manager does a really nice job of pushing information. He's sort of a pusher. Sorry. But he's pushing, what is he pushing? He's pushing the controllers. Okay? You don't get controllers without the manager to install them. You don't get edges or the DLR control virtual machine without the NSX Manager. So the NSX Manager is putting all that stuff out. Well, how does he communicate with the host? He's got 2 channels, and I said I'd come back to that. One of those channels is the vSphere Stateful Firewall Daemon. It's probably easier to say VSFWD. Okay? The VSFWD, oddly enough, works primarily with the distributed firewall. And you'll notice there's an arrow there that points from the manager to VSFWD. Does not go through the controller when it's working with the firewall. That is directly to the host, as opposed to the switching and routing. The switching and routing implementations, configurations, go through the controller cluster. And that is handled with an internal REST API call to the controllers, who then use NetCPA, Network Control Plane Agent, to communicate that information to each host. See, we've got VSFWD and NetCPA there, but that's really on every host. And so the controller will take care of communicating there. Foundational stuff. Everybody cool? We laid the baseline? Okay. Then let's talk about NSX Central CLI. And I'm just going to touch on this briefly, and then I'm going to let Stephen talk about these wonderful, wonderful tables. Okay? The NSX Central CLI allows us to connect to the NSX Manager, where we used to have to talk to each controller individually to find things like the tables. And so you go into one controller and you go, let me have the VTEP table, and the controller would say, not found. So you go to another controller and say, let me have the VTEP table, and the controller would say, try again. You go to the third controller, you go, let me have the controller table, and then you get it. With NSX Central CLI, we can go to the NSX Manager with our CLI, and you see there's commands listed up here we can identify based on the VNI. Based on the logical switch VXLAN network identifier, we can find the tables directly from there. So we don't have to touch each controller. That's just a benefit that was put into 6.2 and allow us to do that. And you can see here we've got segments. If you notice in each of those, I'm on the NSX Manager. It happens to be the NSX Manager on Middle Earth. I don't know where that name might have come from. So the screenshot came out of my lab. But the show logical switch controller master VNI, just as an example, we can see a VTEP table here, a MAC table, and an ARP table from the central CLI and not have to go to each controller itself. There's a lot more you can do with central CLI. Please research a little bit because you can get packet captures, you can get configuration information directly off of the NSX manager instead of having to touch each host or touch each controller. So that's really the benefit of NSX Central CLI. This isn't a class about that. This is a class or a presentation about the tables. And so we're showing you can get those tables directly from the manager. That's all we're showing here, but please look into it a little bit more. It's very beneficial to the development of your NSX environment. Okay? So I am going to hand this little thing to Mr. DeBarros, who's going to teach you how these tables get built.
Okay, good afternoon, everybody. Thanks again for showing up during lunch hour. Thanks, Tim. Okay, so what we're going to do right now is I'm going to explain kind of our layout, and then we're actually going to go through step by step and see how these tables get populated, right? So when I look at my little picture here, what do I see? Well, I have 4 servers, host 1, 2, 3, and 4. Each of these servers, for example, on the left side, host 1 and 2, they have VTEPs. So we just have a single VTEP. We're not showing management networks or anything, just to keep the picture a little clean, right? Over on the left-hand side, again, you'll see you got host 1 and 2 connected to a physical switch. And these VTEPs on the left side are on the 10.10.10 subnet. So for host 1, we'll see that the VTEP's IP will be 10.10.10.11. Host 2, we'll see the VTEP IP will be 10.10.10.12, right? Each VTEP has a MAC address. So we call the one on host 1 MAC VT1, not much of an imagination. Tim put that one up there. Anyway, and then we have the MAC address for the VTEP on host 2, MAC VT2. We repeat the same thing on the other side now. So we have our host 3 and 4. Notice the VTEPs over there on a different subnet in this example. So they're on the 10.10.20 network. And each VTEP has their own IP address. So host 3 has a VTEP IP of 10.10.20.11. Host 4 has a VTEP IP of 10.10.20.12. And the corresponding MAC address is just like before. What else do we see? We see we got our good old NSX controller cluster, right? So again, 3 of them like Tim had mentioned. We also see that we have 2 logical switches here. We have a green logical switch with VXLAN 5001. And we have a red logical switch, VXLAN 5002. You can call that app tier and web tier if you want to. Then we have some VMs connected to these logical switches. So if we start over on the left side, we see we have VMA. It has an IP address of VMA-IP. Again, not that much of an imagination. I did that one, okay? Then we see VMA has a MAC address called AAAA. Just keeping it simple. We'll notice we got VMB with its IP address, VMB-IP, and the MAC address for VMB was BB. And then we just kind of repeat the rest on the other VMs. You'll notice some dotted lines here separating the hosts. That's just to illustrate which host the VMs are running on. So when we start powering on VMs, we'll see that VMs A, B, and C will be running on host 1, VMD will run on host 2, so on and so forth. Okay? So, since we have 2 logical switches, it just goes to say, we're going to have a VTEP, MAC, and ARP table for each logical switch. Does that make sense? All right. We'll actually see, here's showing the central CLI command to display the VTEP, MAC, and ARP table for the VNI 5001. This is showing for the VTEP table on the left. In the middle, we'll see the command, similar command, but for the MAC table. And then over on the far right side here on the top is the ARP table. So we have a VTEP, MAC, and ARP table for 5001. We have another separate set of VTEP, MAC, and ARP tables for 5002. Thumbs up if that makes sense, everybody. Yep, cool. All right. So, and by the way, these tables, so the tables for 5001 could reside on controller 1. The tables for 5002 could reside on controller 2. It's a thing we call slicing. Okay? Or they may still be on the first controller. Who knows, right? It's a thing called slicing. All right. So let's start turning on some VMs. All right. So what I'm going to do is, if you notice now, we just turned on VMA. It turned green. So let's take a look at the entries that would go inside the table, all right? So this is what we would see. Once we turn on VMA, we will see these entries inside the table. Actually, before I even talk about turning on VMA, let's look at the columns in the tables. So first of all, if you look at the VTEP table, you'll see that there's a VNI column and a connection ID column. We'll talk about the connection ID column soon. But you'll notice those two entries in all three tables. So all three tables will have the VNI ID and this thing called a connection ID. That's similar on all three. We'll see in the VTEP table, well, hang on a sec, it's a VTEP table, so it's probably going to have VTEP stuff, right? So we'll see a column for the VTEP IP, we'll see a column for the VTEP MAC address. And we also see a column called network. That's the subnet the VTEPs would be on. In the MAC table, we see that we have our VNI ID and connection ID, just like I mentioned before, and I'll talk about the connection ID, don't worry. But we see we have two entries in here. We have the VM's MAC and we have the VTEP IP. I like to refer to the MAC table as the magic table. Why? Because it basically tells me, hey, if you know the VM's MAC address, I can tell you what VTEP that VM's on. Make sense? That's why I call it the magic table. Then we have our ARP table. We see the VNI ID and the connection ID, and then we'll see the VM's IP address and the VM's MAC. So this is how, again, we can figure out the MAC address of a VM. All right, so we powered on VMA. Boom, this is how it gets populated. We'll see the VNI ID that VMA is on. It's on the green logical switch, which is 5001. So we see that, 5001, right across the board. We see the VTEP IP. So VMA is on host 1, and there's its VTEP. So we see the entry, 10.10.10.11. Excellent. We see the subnet that VTEP is on, the 10.10.10 network. Beautiful. And we see the MAC address of the VTEP, MAC VT1. And as I mentioned before, we see this connection ID. The connection ID, you can kind of think of it as a VTEP, a way that we identify the VTEP. This table, how does these tables get populated? Tim pointed out the NetCPA daemon that gets installed on your server. It's that actually does populate these tables. So when I turn on the VM, a VTEP report is sent out, and this table gets populated on the NSX controller. The connection ID is how that particular NSX controller sees the NetCPA on this host. So it says, oh, thanks for joining the party. I'll give you ID 5 or 6. It was just a random number I just pulled off the top of my head. Okay? That one there is not so important. I don't really look at it too much. Okay, great. So we see this is our VTEP table. So this VTEP just joined the 5001 party line. Then let's look at the MAC table. We see we have the VNI ID and a connection ID. Okay, great. We pointed those out. But we see the VM's MAC address, and we see the VM and the VTEP it's on. So we see VM's MAC address, AAAA, and we see that that VM resides on VTEP 10.10.10.11. Beautiful. Like I said, the magic table. All right. Then we have the ARP table. This table, if you actually went in, it may not have an entry in it. These two tables, the VTEP and MAC, get populated when you turn on the VM. The ARP table doesn't really. It gets populated when there's communication to the VM. So if you're pinging it or it's talking to somebody, boom, it gets populated at that point. So if I don't see an entry here, I'm not going to kind of freak out, all right? But if I didn't see entries here, if these entries were not there and I turned on this VM, maybe I'm having issues connecting to that VM, I'm going to probably look at the NetCPA, because that's what's responsible for this. Maybe I'll check the NetCPA logs on the host. Maybe I'll restart that service. Okay. So let's assume this VMA is not a lonely little VM. Somebody's talked to it. So boom, we see entries in the ARP table. We'll see the VNI ID. We'll see the VM's IP address, VMA-IP in our case. And we see the MAC address, and again, the same connection ID. Does that make sense? Thumbs up if this so far kind of makes sense. All right? This is what it would look like. All right. So let's do another one. Let's power on VMB. How many entries do you think, we power on VMB, it's on host 1, how many entries do you think we would see in this 5001 VTEP table? 1 or 2, folks? Come on, show of hands. 1 or 2? 1 or 2, 1 or 2. I'm getting 1s, I'm getting some 2s. Drum roll. That's my drum roll. Thank you. Okay. We have 1 entry. Why do we have only 1 entry? Well, it's the same VTEP. It's already joined the party. We know about it, so we don't need to put a duplicate entry in there. Cool? Thumbs up? Good. Then we see we have an entry for the VM in the MAC table. All right, so here's, again, it's on the 5001 logical switch. We see the same connection ID. We see the VM's MAC address, BB in this case. And we see the VTEP that it's on, 10.10.10.11. So I know, hey, if I want to talk to the BB VM, I go to that VTEP. And let's assume that somebody's talked to that VM or it reached out and hit Active Directory or something. It did something. The ARP table would be populated. So we would see an entry there. We'd see the VNI ID 5001, the same connection ID. We'd see the VMB's IP address. And we'd see the VMB's MAC address. Everybody cool that? Yes, question?
Isn't there a scenario where if you deployed in a different model, you would have multiple VTEPs within the host?
That's absolutely correct. So potentially you could have multiple VTEPs on a host. We didn't do this in this diagram because that potentially could make it a little bit more complicated, right? But if you imagine host 1 here, let's say had a 10.13 VTEP, right? That VMB may connect to that VTEP and we may have an entry for that one there. Does that make sense, everybody? All right, that's a good question, all right? I just wanted to keep it kind of simple at first. Perfect. Let's do another one. Let's power on VME. So, show of hands. How many entries would we see in this VTEP 5001 table? One or two? I'm seeing a bunch of twos, yeah. Okay, so we would actually see another entry. Host 3, its VTEP just joined the 5001 party line. So we would basically see the entry for it. It's on 5001. We would see the VTEP IP for host 3, 10.10.2011. See the subnet it's on, 10.10.20 subnet. We would see its MAC address, MAC-VT3. And then I just randomly picked a connection ID of 7. You know, I threw a dart at the dartboard. Oh, 7, boom, all right? Then we would see, again in the MAC table, a third entry. We've got a third VM here, right? So we would see the 5001 and the connection ID for that VTEP. We would see the MAC address for VME. It's all E's, E, and the VTEP it is on, 10.10.2011 in this case. So again, like I said, it's the magic table. And last but not least, let's assume that somebody's talked to this VM. Again, it's not a lonely little VM. We would see an entry in the ARP table. See 5001 and the connection ID is 7 to correspond to that VTEP. We would see the VME's IP address and its MAC address. Perfect. Thumbs up if that makes sense so far. Excellent. All right. Well, let's do one more. And let's turn on VMF. Let's turn on VMF. How many entries, now VMF is on host 4, how many entries would I now see in this 5001 VTEP table? 2 or 3, show of hands, 2 or 3, 2 or 3, 2 or 3. I'm getting a bit of both, drum roll. There's the trick, folks. It's in a different logical switch. So it's on the VXLAN 5002, completely different set of tables, okay? So that VM's on a different logical switch, so now we would just basically repeat the process for the 5002 VTEP MAC and ARP tables. Does that make sense, folks? Okay? That was kind of the trick, and I know it's lunch hour, you're hungry, and that was kind of a dirty trick, but thank goodness it wasn't 8 in the morning, because I'd probably get a lot more use at that point. All right? Okay. We've just seen these tables get populated when we turn on VMs. I think we can assume the tables get depopulated as we start turning off VMs. So sort of if I put my presentation backwards, you know, we start going backwards, we see the tables depopulating as we're turning off VMs.
Is that a moonwalk?
That's my attempt of a moonwalk, okay? You try to do it in cowboy boots, man. Anyways. So let me just get these ones back up here. Okay. So great, we turn on VMs, turn them off, the tables get populated and depopulated. Any other time do you think, what other time do you think that these tables would get populated or changed? Bingo, vMotion, yeah. So if I've got VMA over here on host 1 and I decide I'm going to vMotion it to host 2, notice host 2, its VTEP's not even in this table. We would have to do a VTEP, MAC, and ARP report or IP report to populate the tables, okay? So vMotioning stuff around would change the tables. Add entries, remove entries, depending on what you're doing and where you're going. Okay. All right, a couple other things I want to mention here. Of these 3 tables, does anybody know which of the 3 tables we actually send out to every host? Actually, These tables exist on the NSX controller cluster. When these VTEP tables get populated, we send a copy down to every host that's on the logical switch. So in this example, we've got what, host 2 and host 3 right now on this logical switch. These two hosts would actually have a copy of this table, because everybody's got to know about who else is on the party, right? Okay? So we send out a copy of the VTEP tables to every host. The NSX controllers do not send out a copy of the MAC or ARP tables. They maintain that themselves. Okay? The host will actually build its own MAC and ARP table based on the traffic flowing through it. Okay? So I wanted to point that out as well. Now, another thing I'd like to point out. Right now, this is what our picture looks like. So let's say this is my environment that's running. Yes?
The host is building the table. Does it query the controller so the first traffic flows?
The host actually, does it? Okay, so that's a good question. So if you power on a VM, sorry, forget about powering on a VM. Let's say you got a VM on a host that wants to talk to another VM, and it does an ARP. Okay? We can actually, at that point, again, if the host doesn't have the information in its ARP table and the VM doesn't know we can basically go out and interrogate the NSX controller. Say, hey, do you know anything about this VM? And we'll look at the ARP table and say, yes, we do, and we send it over and we tell you now where everything's going. Okay? Good question. Right now in our environment, this is what we look like. If I left this running just like this, and we walk away and we come back next week, and we didn't make any changes, the VTEP and the MAC table would look exactly like this. Wouldn't change. Okay? The ARP table, however, does, I don't want to say flush, but anyways, it does kind of get flushed out. Okay? So this, over time, would basically depopulate itself. Now, what is that time? It's actually the NSX controller not doing that. It's actually the host. The host is going to say, hey, you know what? Nobody's talked to VMA for this amount of time. NSX controller remove its entry from that table. Okay? So the host will tell the NSX controller to flush the ARP table out. Now, what is that time? Static, if your VM has a static address, it's 180 seconds. If the VM has a DHCP address, it's based on the lease of the DHCP. I'm sorry, but you had a question. To keep the VTEPs and the management in the same subnet? No, they don't have to. That's a good question. This NSX controller would generally be in your management network. The VTEPs would generally not be in your management network. Okay? Does that make sense? Good question. All right. So we've seen how these tables get populated. We've seen that vMotioning stuff around can depopulate the tables and stuff. So right now, everybody's talking. Everybody's happy. Let me ask this question. Right now, if I blow up all my 3 NSX controllers, they're all gone. Boom, they all die. Does data stop flowing in my environment? No.
Well, yeah.
Actually, in this example right now, in my picture right now, data still continues to flow. Okay? What's going to happen is, somebody asked a question about the ARP, right? What's going to happen is we're going to start flooding the data plane with ARP requests, right? Just like business as usual. So data still flows if all these controllers blow up. Let me throw this one at you. So all my controllers have blown up. Maybe I put them on a similar LUN, and that LUN died, okay? I now decide to vMotion VMA over to host 2. Wonder if that would work. Or, I wonder if, again, if all my controllers are dead, I wonder if I powered on VMD right now, I wonder if I'd be able to talk to that. Right? So, I wonder why. And that kind of leads us up.
You got a couple more slides to go.
There we go. That leads us up to CDO.
You going to let me do that one?
Yeah, I'll let you do that.
Wow. That was good,
Okay.
Stephen. Thank you. Thank you. So everybody's got a pretty good idea of how the tables get populated now. And we got a pretty good idea of what the controller's used for. And as Stephen just alluded to, the data plane isn't affected if we lose connection with, we got red circles with white X's. Don't ever confuse that with red X's. Okay, that's red circles with white X's. And I do see your hand up. Yes, sir.
Yeah, why doesn't the MAC table get flushed?
It does. Yeah, it's longer time. It's about a 300-second time, whereas the ARP table is about 180 second, but it does actually get cleared out in case there's a problem. The VTEP table doesn't. The VTEP table doesn't at all.
That's on the host level. But anyways, go on.
Yeah. So the target specific scenario where control plane is lost to the host. What is going to happen if I lose that? As Stephen alluded to, it's traffic as usual on the control plane. I can't do my ARP suppression. We haven't used that term yet this afternoon. It is afternoon. The ARP suppression. Anybody hear that? Know what I'm talking about? When I'm talking about ARP suppression, I'm seeing some nods. Stephen says, give me a thumbs up. I see nods. I get a thumbs down if I don't understand. Okay, good. I did get one. You know, ARP suppression. I guess we do, what is it, to do that? Yeah, there we go. There we go. Okay, so ARP suppression says if the controller knows an ARP table that was built through his communication to the host, and an ARP request comes to that VTEP, the VTEP says, I don't know it. I look in my ARP cache and I don't have it. Hey, controller, dude, do you know? And the controller says, well, yeah, doesn't everybody? And he sends back that information so he doesn't have to broadcast that out through the whole physical network. That's ARP suppression. And the use of the controllers in a non-multicast network allows us to suppress that ARP in that fashion and not having to have quite so much data. So this happens. Crap. You know, that's not a good thing. We really would rather not lose connectivity to our controllers. You know, given a perfect world, that would never happen. Do you live in a perfect world? Yeah, me either. It's kind of crazy. So things happen. The controllers are on the management network. The VTEPs are typically on a virtual machine production network or virtual machine traffic network. They're generally not the same network. So there's reasons we could lose connectivity, right? Routing doesn't take place. We lose connectivity through a network. We have a switch break, whatever. But our data plane will still allow traffic to flow, provided there's no changes. As Stephen alluded to, life is good. We just keep on keeping on. But when you try to vMotion something somewhere, or you try to power on something somewhere on a host that wasn't part of the VTEP table yet, sorry, Charlie, ain't going to get there from here. So what we do with CDO mode, there's a bullet point here that basically says at the bottom, that basically says what CDO does is makes another switch to handle this bum traffic. And bum isn't a derogatory term for some of the people that you see walking across the bridges. The bum is broadcast, unknown, unicast, and multicast traffic, right? That's a definition of a certain type of traffic that has to be propagated in order to get ARP requests answered, in order to pass frames to some place that is unknown. So if we lose connectivity, that's a bad thing. What we can do, and this is enabled at the transport zone level, okay? Most organizations that I've worked with have a single transport zone, okay? Unless they've gone cross vCenter. The reason there was a choice of creating multiple transport zones at the beginning of NSX is that there was, prior to VMware taking it over, there was multiple overlay protocols that were used besides VXLAN. And so each transport zone would be unique to the overlay protocol. Now we're just completely VXLAN, and that's why we typically only have one transport zone that's enabled. Unless we go cross vCenter. If we go cross vCenter, we're going to create a universal transport zone that's going to allow the universal objects to exist. So we could have two. As it says in the slide, we have an exception there in having the ability to create a multiple, if a distributed logical switch contains both a local transport zone and a universal transport zone, I can still use CDO and make that work. It doesn't require cross vCenter, but it is a really good use case for cross vCenter to allow that universal logical switch, a universal transport zone to allow the bum traffic to take place. Anyway, you do see CDO is enabled there. It's very difficult to do. On the left-hand screenshot here, you can see how difficult it is to enable CDO mode. Okay. I hope I didn't go too fast through that one. Okay. So it's enabled. Now we talk about putting CDO in place by enabling it, and it will create that universal logical switch. It's hidden. You don't see it. It's created. It doesn't exist down there, but it is. It does exist. And that is going to grasp the next available VNI. That's that VXLAN network identifier. So I've used 90,000 90,001, 90,002, so the next available will be 90,003. So it's going to grab that one and create it. All hosts will automatically join the CDO logical switch. They'll all join that so that the bump traffic can be carried. Okay? That's pretty good. We're not sweating too much, you guys in the front row. You're not seeing? Not too much? Okay, good. The global VTEP list is then maintained by all the hosts. Remember, all the hosts have all the VTEP listings. That's how the VTEP tables work. So they're going to have all the different listings of all the different hosts that are included in there. So if control plane connectivity is lost, we'll still be able to pass bump traffic and make things happen. Watch what happens. Oh, I just added another logical switch. Well, where did 90,003 go? It's hidden, CDO mode, so the next logical switch we create does take the next VNI. So for control plane resiliency, and what we want to make sure is happening, this is a short version of our tables here, right? We've got the VTEP table for a VNI. It's 5,000, over here on my right side. The VTEP table includes hosts 1, 2, and 3 because there's live VMs on those 3 hosts. Excellent. So if I migrate or vMotion a VM over, well, that's no problem. It happens, no change in the VTEP table. Everything is hunky and dory. If I power on a virtual machine on host 4, look what happened to the VTEP table. Okay? Just like Stephen was just showing, you power on a machine, the VTEP table grows. It comes from a VTEP report from the VTEP to the controllers, and then that gets pushed out to all the VTEPs. So now all the VTEPs know that there's hosts 1, 2, 3, and 4 all together. Perfect. That's what should happen. Powering on or vMotioning, I'm happy. Very happy until that happens. Okay? That red circle with a white X happens again. Rats. Really don't like it when that happens. So the hosts are disconnected. Some reason, switch breaks, routing breaks, whatever. I've lost connectivity to the controllers. Data affected as of this moment. Is their data effective? Yay or nay? Nay. Excellent, excellent. Hosts are disconnected. Now I vMotion from host 2 to host 3. We get a good green arrow. Why? Everything's good. He's in the VTEP table. Life is good. So what do you think? Because guess what I'm going to do next? I'm going to power on that machine on host 4. What's going to take place? This is pre-CDO mode. If I power on a machine on host 4, thou shalt not pass. Perfect. Perfect. I left my staff up downstairs.
I told you to bring it, man. Honestly, I didn't tell him we had one.
I was trying to figure where I could put that into this presentation, and you did it for me. Thank you very much. You know, I'm going to tell you, we have an education lounge. Has anybody been to the education lounge yet this week? Yes, yes, yes. Okay. In the Facebook page for VMware Education, we have recorded all of our sessions that we did. We did small breakout or small presentations, 30-minute presentations, and for a little while they're going to be available on that page. They're going to put them into VMware Education's Learning Zone, but for now you can see them, and you will see "Thou shalt not pass" if you look at the firewall presentation that I did there. Yes, sir.
So going back when you were just showing, which one? I think it was the VM going from 2 to 3. Yeah, there you go. So if the VM on host 1 didn't have that VM that moved in its VTEP to VM MAC table,
right?
It wouldn't be able to communicate though, right? Because it would have to go to the controller to get that.
Since he knows, remember the VTEP table has been distributed to all the hosts. So he knows everybody that's on there, so he can do a MAC search with ARP to find it because he knows all the different VTEPs. So he will get the MAC address the old-fashioned way instead of using the shortcut by going to a MAC table on the controllers. Make sense?
Yep.
All right. Good. Thank you. Good question. Great question. Okay, so that worked. It was good. We're happy. This didn't work. We're unhappy because I can't talk to the new machine. The new machine can't talk to anybody. I mean, it's a lost connectivity. Bad news. Ooh, I hate when that happens. So with CDO, we got host 1, 2, and 3. VNI is set up. Lose connectivity, but we created the CDO logical switch. So bum traffic can take place and we can get VTEP information. All the hosts will now have, I know where the VTEPs are. And since I know where the VTEPs are, if I power on a machine, yay, green arrow. I like green arrows. That was a shiver, not because you were cold. That was just because it was such a cool thing, right? Yeah, yeah. It really, yes, sir.
So is it just sending the traffic to figure out where the VTEPs are?
Right.
So once it sends the bulk traffic at that point, it'll find the VTEP, and then it just goes back to read.
Then it'll just go back to the good old-fashioned way. I'm going to ARP off of all the VTEPs, and I'm going to find that sucker. I'm going to send him where he needs.
So let me ask another question.
You don't get to. Yes, sir.
Why is this just not built into the regular VTEP?
You know, it's a new feature that we just built in. So as progress, I don't, future, I'm not sure exactly, but it's something that we took place. Okay? Good follow-up. Yes, sir?
What is the use case for not enabling?
I haven't figured that out yet, but that's a good question. Yeah, like I just said, we just developed this technology, and it is available to us today, and we're grateful for it. And check mark feature, it's easy to implement, and away you go. So I think it's good. It's awful tough. It's awful tough. Did y'all catch that? Yeah, I think it's a really good idea. Okay, we're actually.
There's a question in the back.
Oh, I'm sorry. Yes, sir. Can you hear me all right?
Can you hear me too?
I'm getting there. There's a microphone up here if you'd like to. No, go ahead.
I'll try my voice.
You're good.
So with your example, you showed before you started on enabled CDO, you indicated host 4 was not powered on.
Host 4 was powered on the VM. There wasn't a VM for that VNI on host 4.
Okay, because when I read the red line, I thought it said that the host was not powered on.
If it did, it should have said the VM was not powered on.
Thank you.
You're welcome. Thank you for clarifying. I appreciate it a lot. Okay. Oh, good. You guys, this is good. I don't know who got first. You got a hat on.
Oh, okay. So I assume, let's say you have a VNI 5001.
Congratulations.
That actually has an active VM on host 4. That
Perfect.
will still be communicating fine.
Sure.
So
On 5001.
So this is per VNI or okay.
As Stephen said earlier, remember we have the two tables. Yes, it's per VNI, but the transport zone is across all the VNIs, so I can get that bump traffic. Okay? All right, very good. Yes, sir.
Once the CDO mode comes on, what is the eligibility protocol or rules for which host is coordinating the communication? Or is it
Controllers, the controllers are going to send out. Well, that's a good question. Stephen, do you know?
It's based actually on the host. If the host cannot see the NSX controller, it goes into CDO mode. Okay.
once they are now all 4 hosts are CDO mode, how do they coordinate? How do they? If there's a change in information, how do
That's
they
good.
coordinate that?
That's good. Now let's think about. Wait a second. Let's think about what CDO mode did. What did CDO mode do? CDO mode created a new logical switch that all the hosts were a part of. And what happens with VTEP tables? Where do they exist? They existed in the controller and got pushed out to every single host. So when CDO mode is enabled, every single host has all the VNIs for all the different inputs. So there is no need to have master replication or anything like that because each host has its own table. Does that make sense? Okay. Awesome. Right. Pretty much to let that take place. Wait a minute. Where's our questions? Thank you. Yeah, of course, thank you. No, we got a bunch of stuff to talk about yet, but let's just leave it open for questions for a little bit yet. Anybody else? That's good. I love the discussion. Okay, you're 2, you're 1. You're 1.
What happens if you power on a new host with CDO host?
That's good. That's good. Power on a new host. So the cluster would have, say again?
The clusters would see the host come up.
Right. The cluster sees the host come up. The transport zone is not going to. Steven, do you know for sure? I don't think he's going to.
It's going to join that VNI, the CDO VNI, right? So the NET CPA will basically go and say, okay, we got CDO mode enabled. We need to do a VTEP report to the NSX controller to say, hey, we're joining that party line, and then that gets pushed out to all the other hosts.
There's no controller.
Sorry?
There's no controller.
Oh, sorry.
Controls are also down.
Controllers are dead in the water. Yeah, you're dead in the water at that point.
I don't.
So
I don't.
If that host doesn't exist, and then you power it on, that's not going to help you out. Good question. Sorry.
Don't power on a new host. If
Power
you're
on all the hosts.
You're number 3. You got the 3 up. Yes, sir.
So I guess it follows on with the same logic as we add new hosts or no DLRs. This is just basically just saying it's going to bring up a logical switch. We're not going to be able to add DLRs and edges.
Oh, no. You do not have the controllers to pass that information to. So major changes are you're going to wait until the controllers are back up and connected. But for the ongoing data flow, we're going to be able to maintain that. But no, you're not going to be able to put a new DLR in or a new set of switches. Continuity of data, that's a great way of saying that. I don't know if you could hear him. Maybe you heard me. He said continuity of data is maintained by CDO mode. Back there, number 3.
Yeah, I guess the question for me is what happens when the controllers come back online? Do they query the hosts for the existing tables, or do they go back out and
Remember, it's a different set of tables, the different logical switch. The CDO is its own logical switch. So the others are going to be, oh, good, we got our controllers back. All of our logical switch information is now available to me again. So I'm able to take the IP reports and the MAC reports that I'm getting off of the VTEPs. They're going to repopulate in the controllers and repush out as queried. Okay, you are almost, wow, this is good. I think, hello? Yeah. Correct. It's per transport zone. Well, if you've got universal and a local, you can. That's the exception. Okay? Okay, very good. Now, there was one over here, and then I got you 2. Sir? It's interesting what happens. Okay, you can run with one controller. I do not recommend it. I do it in the lab, but that's not recommended for production. You need to spread the load. You need to have some redundancy. If you lose one, right? You got 3. You lose 1. How many does that leave? 2. Okay. Things are still working. We redistribute the slices. Stephen talked about earlier. We redistribute the slices to the 2 existing. What do you think happens if you lose another one? Any idea? What do y'all think happens? You go, oh, you are smart. You've read the white papers. That's good stuff. Okay. It goes into read-only mode, and basically the controller is no longer updating. So losing 1, still working. Losing 2, no changes. You're going to have to get your controllers rebuilt and get them active again. Okay? Good? All right. There's a couple over here. Yes, sir.
So his question.
Well, then he'll go first. You go, sir.
No, his question about turning on the host.
Oh.
The controllers are down.
Right. Yeah, sure.
Don't do it.
Don't do it.
Is there any mechanism to lock out the ability to turn on a host when the controllers are down?
I don't think so. I don't think so. That's a great, talk to your TAM and make sure that gets implemented as a feature request, because that would be a great idea. Yeah, and we label, we got a lot of bumper stickers labeling, don't be stupid. That would be good. That'd be good. Don't push the red button. That one too. That one too. Thank you. Good job. Good question. Yes, sir.
Just as a summary, the CDO component that changes with the power on for alpha
Right. Pretty much. I mean, you can't make any other changes. You can't add any new logical switches. You can't do anything that has to come from the manager through the controllers down to the host. It's survival mode. As he said, you know, it's a continuity of data flow. Yep.
I'm curious with...
I'm glad. You should be.
Is there any integration with DRS so it's aware? So if your controllers go down, is DRS aware of the fact that your controllers go down so as not to vMotion if you don't have CDO enabled?
No, there isn't. Another good feature request to your TAM. Okay, good feature request to your TAM. Yes, sir.
I'm trying to think of the use cases here, and really the only thing I can come up with is if you're running a dedicated failover host, because you already have it up online, and then it's going to, CDO will protect you, stuff like that.
That is a very appropriate, but you might have, you know, the bulk of your virtual machines have been migrated over to a couple hosts. If you're using DPM. You know, how many of you use DPM? Let me see a show of hands. Who uses DPM out of their DRS? Yeah, that's the number I thought I'd get. Okay. It's so cool. The video on YouTube is so awesome, but nobody uses it.
Is it going to treat it if it's standby like it was power off anyway?
Yeah.
So it's not going to help you.
Right. No, actually it would. It would power on. If I needed the resources, it would bring up power on. Okay. Yes, sir.
I was just going to say, in case it was not obvious, I think the clear lesson here is if your controller cluster's down, fix it.
Amen, brother. That is exactly. Did anybody hear him? If your controller cluster's down, fix it. That's your best bet. It'll limp you through as you're fixing it. The CDO mode will limp you through as you're fixing your controller cluster. That's perfect. That's perfect. Thank you. You're going to use that.
She had a question.
Well, hi there. I haven't seen you. I'm glad you're here.
Hey, if you're having a really bad day and
like today?
the systems that you have that's running your management cluster, they're offline, and you happen to lose one of the VTEP hosts, one of your hosts that was already in the VTEP table, what happens then to your data plane?
Yeah, you lose connectivity to that host. I mean, that host is gone. Not on that host, because he got bad news.
But the VMs would HA over to another one.
The VMs would HA, so they'd still, it is HA compliant. So you know they'd vMotion, they'd still be available, and they'd still be able to talk to each other. The old-fashioned way again. Let's remember, we aren't going to do any ARP suppression. We aren't going to have any of that, but we're going to have to communicate with the old-fashioned way. Good question. I do see you. Exactly. It's really best use case is cross vCenter. It's keeping all the different VTEPs. Exactly. Great question. Thank you for bringing that up. 1 second, okay? Yes, sir.
The example you have here is when your entire NSX control cluster goes down.
Right.
The hosts are in CDO mode.
Right.
What happens if you have one host loses connectivity to the cluster? It goes into CDO mode and it comes back on. What happens to the host? The table changes.
They're going to get propagated back from the controllers to the host. Yeah, it's integrated. It would work good. Yes, sir.
Yeah, why cannot pick up the VTEP table from the neighboring host?
They don't communicate that way.
No, but they can, in the CDO mode, they can make to communicate and pick up the table from the...
They have the tables built that came down through the CDO mode. Enablement publishes the VTEP tables to all the hosts. It publishes to all the hosts. You can't enable CDO mode when you don't have access to the controllers. You have to do that ahead of time. It's kind of like when you play a video game. You know, you get to that certain point and you die. You don't save then. All right, thank you all very much. Hey, do a survey. Please do your survey and take advantage of the Education Lounge and look at VMware.
Thank you, everybody.
Facebook for VMware.